Hello students, so today we are starting our one topic nomenclature to start organic chemistry. See, organic chemistry is very important for us to study because it helps us almost in every aspect of life. Organic compounds are involved everywhere. You take all drugs, medicines, polymers, so many things are there which are linked to the organic chemistry only. Now, in the organic chemistry, as a whole, when you take syllabus wise or weightage wise in examinations, organic chemistry have almost got 1/3 weightage in your almost all entrance examinations. So, organic chemistry cannot be neglected, cannot be left for any reason. And organic chemistry is very easy. The student feel it very difficult. सर होता नहीं है, समझ में नहीं आता है. उसका रीजन क्या होता है? If for understanding organic chemistry, you have to be clear in some concepts. Like what concepts? First you can take atomic structure, where we take the structure of orbitals, quantum numbers, their significance, and nodes, all these points. Then periodic properties, the properties like taken size, ionization enthalpies, electron gain enthalpy or electronegativity especially, and then chemical bonding concepts. Chemical bonding because covalent bonding only will be involved in the organic compounds structures. Carbon compounds show the property of catenation to very highest extent. Carbon is the element which show maximum catenation tendency. What is catenation? The self-linking ability of atoms of elements to form long chains or ring structures. So that's the way there. Now to start here organic chemistry, in this topic nomenclature, we will not take only nomenclature but we introduce to you organic compounds, the basic idea of the organic compounds from where we started, and then common names and some naming of the substituents, and then the compounds IUPSC name. So this chapter is mainly focusing on this organic compounds classification, their basic structure and the nomenclature. Nomenclature can be taken common names and then you can take IUPSC names of the compounds. That we will discuss in the given topic nomenclature. So we can take in chapter what we are going to discuss. First we take introduction to organic chemistry, organic compounds. Then you can take here basic structure of means carbon tetravalency, small introduction. Tetravalency of carbon. Just some idea of sigma bonds, pi bonds, calculation of sigma bond, pi bond in organic compounds. Then you can take classification of organic compounds. Then you take common names, and then we take the compounds IUPSC names. So in the given topic nomenclature, we will focus especially on IUPSC names, and some common names are also equally important because they are so common that they are also accepted in the compounds IUPSC nomenclature. So this chapter's majority part is dealing with the IUPSC nomenclature, but we will take introduction of this other terms as well. Now to start here, first we will introduce to you here about the organic compounds. See, this property of organic compounds or organic chemistry as a branch started around 200 years back. This organic chemistry as a whole, as a branch, started around 200 years back. See, this is mainly linked with the catenation property of carbon. It is linked to the catenation property of carbon. What is catenation is already we have made clear to you in some p block elements, that it is the self linking ability of an element. It is the self linking ability of atoms of a given element to form chains or rings. Organic compound you find mainly there many compounds are open chain structures, and we have many compounds, cyclic compounds, aromatic compounds, they have ring structure as well. So this is mainly because of the carbon's catenation ability, which led to an entire separate branch called organic chemistry. Now we can take in the earlier it was thought that organic compounds have the source only from the only from living organisms, maybe plants or animals. But in the year 1828, we have one scientist, F. Fuller. In year 1828, he synthesized urea from inorganic compound ammonium cyanate. That is what you can take NH4 CNO on heating. This compound is called ammonium cyanate. This compound decomposed to give NH2 CO NH2. The first you can take organic compounds. The first organic compound synthesized chemically, means from chemical compound, inorganic compounds, was urea. It was discovered in the year 1828, and then later on you can see we have scientists. We can take here acetic acid was synthesized in the year CH3COOH in 1845 by Coles, and CH4 methane by Berthelot in year 1856. They were the pioneers to start the synthesis of organic compounds, and now after the structure of structure of atom, electron discovery, the entire branch or organic chemistry get the modern view, and then we introduce modern concept like orbital diagram, hybridization concepts. All this they will modified after the structure of atom discovery. We have already discussed in 1911, and then work done by Schrödinger in 1929-27, that orbital diagrams, concept of orbitals, 3D space. So that is to start here the organic compounds. Now before we take classification or other things, we can take basic structure of carbon's tetravalency. That carbon have tetravalency. Why? This can be explained here. See, carbon is tetravalent. Why? It can be explained from carbon's electronic configuration. When you take carbon's electronic configuration, outermost shell, it is the carbon's configuration 2s and 2p orbitals in the ground state. 2s orbitals, 2p orbitals in the ground state. After excitation, we can have carbon can have 4 electrons in the valence shell, 4 electron unpaired in 2s and 2p orbitals. This is the carbon in the excited state. So carbon have 4 electrons in the excited state which are unpaired. So carbon is able to form 4 bonds, and there is no 2d orbitals. We don't have 2d orbitals at all in carbon, because when n is 2, L value is 0 and 1. 0 indicate S and 1 indicate p orbitals. So in this case there is nothing about vacant 2d orbitals. That's the reason the carbon can have only 4 bond maximum. Only 4 bond maximum means carbon so tetravalency can form 4 sigma bonds maximum or pi bonds including. So if it is taken by orbital diagram already discussed, if you take the structure of methane, this indicates the carbon's tetravalency. Tetravalency of carbon is linked with this property of 4 unpaired electrons on carbon atom. When you take methane structure wise, it have hybridization sp3. Then you can take here ethene. In ethene CH2 double bond CH2. In this case, carbon atoms are sp2 hybridized. Each carbon atom is sp2 hybridized. Already having given structure, both carbon atoms are sp2 hybridized only. And then you can take acetylene, in which carbon atoms are sp hybridized. Here in alkynes or acetylene, carbon atom are sp hybridized. Both carbon atoms are sp hybridized. Now what happened by this hybridization? We have discussed this point, if you remember or recall, in chemical bonding, that the electronegativity of an atom is directly proportional to percentage S character. In the hybrid orbitals, in sp3 orbitals, each bond have how much percentage S character? They have how much S character? 25%, because we have taken one S orbital, 3 p orbitals, and this carbon have how much S character? 1/3 means 33.3% S character, and this case carbon atom is having 50% S character. 50% S character. This indicates that when the carbon is having different state of hybridization, then sp carbons are most electronegative, then sp2 carbons, and then sp3 carbons. When you take carbons electronegativity, sp carbons are more electronegative than sp2 carbon and then sp3 carbon atoms. Hybridization is very important concept here, because it is indicating this carbon atom electronegativity, that sp carbon is more electronegative than sp2 carbon than sp3 carbon. Also the bond length will be affected because of carbon's different hybridization. Here when we have less S character, attraction is less, so they have longer bond length. Already discussed, remember, in chemical bonding. When we have more S character, there is more attraction for the orbitals, so they will have shorter bond length. And when we have less S character, longer bonds are there, or we have longer bond lengths. Now this structure can be explained by using ball and stick models for understanding the structure, or using space filling model. It is methane. If I write ethane, can be explained here and explain both. If it is ethane, in ethane also carbon atoms are sp3 hybridized. In ethane, carbon atoms are sp3 hybridized. Both carbon atoms. This I'll explain to you this first space filling model for methane and ethane, and then I'll explain them by using ball and stick model. See, this can be taken methane molecule. This can be taken methane molecule. If you take structure wise, carbon atom is here tetrahedral. Black one is carbon, white atoms are taken hydrogen atoms. So you see, anyway the shape symmetrical type is there. We have symmetrical shape. Look this way, or this way. All the bonds are seem to be identical. It is methane molecule. It is called space filling model. Actually, when there is no space, there is overlapping of orbitals. That is the actual structure. There is overlapping of orbitals, and then the shape is not spherical exactly here. That is what we can take the methane structure wise. This can be taken ethane structure wise. We have two atoms are black carbon atoms. Black one are carbon atoms, and white one all taken are the hydrogen atoms. So in this case, if you see here, we can see the structure two way. Around the carbon-carbon single bond, rotation in space is allowed. You can see from there, you see only one group, हाइड्रोजन ओनली फ्रंट कार्बन. आपके लिए फ्रंट कार्बन में ये एच होंगे, खाली आपको ये एच दिखेंगे. जो यहाँ बैक में हाइड्रोजन आपको दिख नहीं रहे होंगे इसमें. एग्जैक्टली दे आर इन ओवरलैपिंग बाय द फ्रंट कार्बन ऑन द बैक कार्बन्स. So the group on the front carbon cover the group at back carbon completely. That I'll explain to you topic conformation phenomena in detail. But यहाँ पे क्या around single bond rotation can take place. Now when rotation take place, you can see From the front side you can see the group of back carbon also hydrogen completely. Now you can see 6 hydrogen atoms. If you see here, from your side you can see 6 hydrogen atoms completely. If I say I can see, so you can see 1 2 3 4 5 6 atom are visible to you. ठीक है ना? तो around the carbon carbon single bond rotation in space will be allowed that can give rise to phenomena of called as conformation phenomena. It is the structure of taken ethane molecule. It is called as what we write here. This is taken space filling model. Such kind of arrangement is called space filling model of ethane. Now if I take ethene and acetylene, now if we take an ethene structure, between the two carbon atoms we have one sigma bond and one pi bond, and then this is the pi bond. Sigma bond is not visible here, आपको draw नहीं किया है. Now this can be taken the ethene structure wise. आप देखिए ऐसे करके यहाँ पे we can see all the atoms, 4 hydrogen, white are hydrogen atom, and black one I have taken carbon atoms. 4 hydrogen atoms and 2 carbon atoms are in same plane, and to this plane this pi bond is perpendicular. To the plane of the ethene molecule the pi bond is perpendicular, and the pi bond's nodal plane will be in the plane of molecule, already explained in chemical bonding concept. So it can be seen this way here, all the atoms are lying in same plane. So ethene molecular structure called as, what we call the structure as planar structure. Each carbon, around each carbon geometry will be trigonal planar. So as a whole molecular geometry or shape trigonal planar. All the atoms are in same plane. To the plane of pi bond and to the plane of molecule the pi bond is perpendicular. Now next can be taken the structure of acetylene in orbital diagram. When carbon atom are sp hybridized, what is the shape? Shape will be linear. Geometry they acquired is linear because in sp hybridization of both carbons, it is one carbon. So the two carbon atom have sigma bonds, which is not visible to you here. I just shown the pi bonds here. We will show 2 pi bonds. We have 2 pi bonds. The plane of the molecule, these pi bonds are perpendicular. One pi bond here and second pi bond in this plane. It is the plane of the molecule, not plane linear shape we have. So it is alkyne acetylene where 2 atoms of carbon are sp hybridized. Shape around each carbon is linear, geometry linear. Carbon carbon have one sigma bond by sp overlapping, and sp2 sp and sp overlapping we have one sigma bond on each carbon. That is the structure of taken acetylene. Now after the structure taken of acetylene, for drawing the structure of organic compounds we can take 2 kind of arrangements. We have 2 structures. One is called as complete structure and second is called as bond length structure. यहाँ तो एटम कम थे, सिंपल था आपको लिखने के लिए. Now suppose we take long carbon chain, we have many atoms, then we are drawing the bond length structures. वो कैसे करते हैं आपको दिखाते हैं. उसके पहले क्वेश्चन आपको दे रहा हूँ, उसमें आपको बताना इसमें नंबर ऑफ सिग्मा एंड पाई बॉन्ड्स. ठीक है, देन we will take the next point. आपको क्वेश्चन दिया हुआ है CH2 डबल बॉन्ड CH, CH2 C ट्रिपल बॉन्ड C CH3. दिस कंपाउंड इज गिवन. आपको बताना इसमें क्या है, फाइंड द नंबर ऑफ कार्बन कार्बन सिग्मा बॉन्ड्स, नंबर ऑफ कार्बन कार्बन पाई बॉन्ड्स, number of carbon hydrogen sigma bonds in this example. Find the answer yourself. So let's try the answer for this question. बहुत easy question है. आपको मैंने bonding में काफी सारे example किए थे. यहाँ पे क्या है, in such kind of case write the structure open to avoid any confusion or doubt or mistake. यहाँ पे carbon C, 1 hydrogen, again C, 2 hydrogens, again C, triple bond, फिर C, H3. And now you can count the number of all kind of bonds. कितना आपका है sigma bonds? We have how many carbon carbon sigma bonds? 1, 2, 3, 4, 5. You have 5 carbon carbon sigma bonds. Then how many CC pi bonds? 1, 2, 3. 3 carbon carbon pi bonds. And how many CH sigma bonds? अब काउंट कर लीजिए 1, 2, 3 4 5 6 7 8। जितने आपके हाइड्रोजन होंगे उतने आपके होंगे कार्बन टू हाइड्रोजन सिग्मा बॉन्ड्स। कितने आपके हाइड्रोजन हैं? 2 3 + 2 5 + 3 8। 8 हाइड्रोजन मीन्स वी हैव 8 कार्बन hydrogen sigma bonds. So if they ask total sigma bonds in the compounds, you can add here 8 + 5 13 sigma bonds and pi bonds in total 3 only. That is, we have 3 pi bonds and 13 sigma bonds in the molecule, this one here. Now sometime we are write this kind of structures, we write all the atoms, we can write them for simplification into bond line structure. Now next we'll take next one here, the structural representation of the organic compounds. How for the organic compound structure can be represented here? We can draw here several structures. One is called complete structure or formula, second called condensed formula, and third is called bond line structural formula of the compounds. In the complete structure, we indicate all the atoms, including lone pair, whatever we have, we indicate all the things. So if I take some examples of compounds, complete structure. In the complete structural formula of the compounds, if I suppose write methane, so methane I will write this way here, without drawing the actual shape or hybridization. I'm just drawing here. If I suppose take a ethane, so how to draw ethane? It is the compound's complete structure. Means it is methane, it is ethane. If I take ethene, it is ethene. If I take acetylene, we can draw already, we have shown to you. It is acetylene. If I draw methanol, CH3OH, O have two lone pair, this is called as methanol. If I write acetaldehyde, CH3CHO, this compound can be taken acetaldehyde. Such kind of structural formula where we write all the atoms, we indicate all the sigma bonds, pi bonds, lone pair on the atoms, is called as the molecules compounds complete structural formula. It is the compound complete structural formula. Then how to write condensed structural formula? Let us see next one. If you take for the molecule condensed structural formula, we don't write all the atoms separately, just write complete structure. Like if I take methane, how we write CH4. If we take ethane, CH3CH3. If I take ethene, CH2 double bond CH2. If I take methanol, CH3OH. If I write suppose acetic acid, then CH3COOH. If I write acetaldehyde, CH3CHO. So such kind of structures where we write the formula of the atoms together, it is called as the molecules condensed structural formula. Now again they take some more time for drawing as compared to complete structure. So it is understood that carbon is to maintain tetravalent, and we can write condensed structure, and we also can write for the molecule the bond line structure. So how to write this last one, bond line structure, we can try to explain here. Now next one can be taken bond line structural formula. Actually they are very simple to write because we can write them in very less time, quickly, and making the entire meaning clear. So in this case we don't indicate the carbon and hydrogen atom at every place. In some place we indicate when we have compulsorily, otherwise we don't indicate. If we take for example, we take the example of when we will use such structures, especially when we have longer hydrocarbon chain, longer chain structures, more atom are there. In such kind of case, we write the bond and structure of the molecules. Like if I write here, for the compound taken CH3, CH2, 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 CH3. This compound is taken 1, 2, 3, 4, 5. This name is pentane. How this pentane structure we can write by writing this bond and structure. See, if I write this structure open, complete structure, you have 3 hydrogen atoms here, 2 hydrogen atoms on each carbon rest. This structure can be written this way here. I write here itself for clarity. CH3, 1, second carbon here, third carbon here, fourth carbon here, 5 carbon here. We have 5 carbon atoms. 1, if I write carbon number suppose 1 here, then 2, 3, 4, 5. Number 1 carbon, 2, 3, 4, 5 carbons. So first carbon have in this case how many bond visible to you? Single bond visible. That means there are 3 more hydrogen atoms which are not drawn here. This carbon have 3 bonds more. So because carbon to maintain tetravalency, carbon maintain tetravalency will have 4 bonds. Only 1 bond visible to you, 3 bonds not visible. That means we have 3 hydrogen atoms on first carbon. Carbon 2 have 2 bonds visible. We are only indicating here carbon-carbon bonds between the 2 atoms of carbon. So we have carbon-carbon 1 and 2 have single bond. Again 1 more bond is there. That means carbon 2 have 2 bonds. So it have 2 more hydrogen atoms to maintain the carbon tetravalent. Similarly carbon 3 or 4. Each carbon have 2 carbon-carbon single bonds. So they will have 2 hydrogens more which are not visible here. Again carbon 5 have single bond visible, so they will have 3 hydrogen atom more on this carbon number 5. That is how we can write this structure. One example. Let us take some more examples on this bond and structure. If I write the structure of CH3, CH, CH3, CH2, CH, double bond CH2. Suppose this structure write this way here. So how to write the structure of this compound here in the bond line structure? देखिए यहाँ पे क्या है? On atom either we put numbers. Numbering is not for nomenclature. It is a simple numbering 1, 2, 3, 4, 5. We draw one chain having 5 atoms इस तरह से 1, 2, 3, 4, 5 हो गया. Now on carbon number 1, it is one number have 3 hydrogen atoms. तो already balance है. Carbon 2 have 1 hydrogen only. So they have one more CH3 group. This group is written here CH3 group. And then again carbon 3 have 2 bonds visible to you. That means यहाँ पे क्या carbon, this extra carbon, if I write suppose 1 dash, it is 1 dash carbon 1, 2, 3, 4, 5. Now carbon 3 have 2 bonds visible. That means there are 2 more hydrogen. Carbon 4 have double bond. So we draw double bond directly. 4 and 5 carbons are having double bond. We write directly double bond between carbon 4 and 5. Then we have 1 hydrogen. And we have 2 hydrogen on the last carbon. आपको 2 बॉन्ड दिख रहे हैं यहाँ पे, 2 बॉन्ड दिख नहीं रहे हैं. जो दिख नहीं रहे हैं वो क्या होंगे? हाइड्रोजन एटम्स. तो यहाँ पे 2 हाइड्रोजन होंगे, यहाँ पे 1 हाइड्रोजन होगा क्योंकि बॉन्ड 3 यहाँ पे दिख रहे हैं. That is how we can draw the structure for this compound. If I take next example taken here, CH3, CO, CH2, CH, CH3, CH, double bond CH2. How we write this structure of compound? देखिए इसको कैसे लिखेंगे यहाँ पे? When we have double bond taken in the functional group here, so we write 1, again carbon 2, 3, 4, 5, 6. Draw double bond here in the carbon chain, and then it is number suppose 1 carbon, 2, 3, 4, 5, 6 carbon. It is carbon number 1, 2, 3, 4, 5, carbon number 6. Now carbon 2 have a double bond CO So when we have functional group, we indicate completely. Like CO is ketone, functional group, write CO group here. Carbon 4 is having one CH3, write CH3 group, this one here. Then 5, 6 have double bond, it is same. So this structure can be written this way here for this molecule. If I suppose write here CH3, CH, OH, CH2, COOH. How this can be written in the bond and structure? So we take a 1, 2, 3, 4 carbon. So 4 carbon you write here 4 atoms. बहुत सिंपल तरीका है इसमें आपके 4 atoms. Then at second we have OH group. OH group write completely. In OH we have hydrogen. We should write. In the main carbon chain only we are not writing hydrogen atoms. But in the functional groups or other side chains they have hydrogens. If required we have to write, then we write. Carbon 3 CH2 C पे क्या है COOH. How we write COOH group? This is for this molecule bond line structure. Okay, if I take for benzene, how to write benzene's bond line structure? Benzene or can take first some cyclic compounds like we have CH2 CH2 CH2. It is cyclopropane. Cyclopropane. Four carbon name is cyclobutane. How to write this cyclopropane structure wise? This can be written in bond and structure this way. If I take some group is extra like CH2, CH, CH3, CH2, CH2, CH, OH. Then how this compound we write in the bond and structure? This can be written this way here. We have 5-membered ring. 1, 2, 3, 4, 5 atoms. So 5-membered ring draw you first. First to draw 5-membered ring. Then this side we have one CH3. CH3 को लिखने का रिक्वायरमेंट नहीं होता है. It is understood. It is CH3 group. Then this पे क्या है OH. OH we have to write. Same compound we can write this one here. Name is same of the compounds. We discuss nomenclature in the next part coming. But this only structure writing. They are simple to write, so we are writing the structure this way here. If I write, let us say benzene. How we write benzene structure wise? What is benzene structure? CH, double bond CH, single bond CH, single bond CH, double bond CH, single bond CH, double bond CH. It is benzene. How we write benzene in the bond length structure? We don't indicate hydrogen atoms here. We have double bond 1, second, third double bond, alternating positions. In benzene we can place any extra group like COOH. If I place suppose OH group, sorry, CH, you can take here CH2OH group, here CH2OH group, here COOH group. How this compound you can write here in the bond line structure? तो पहले क्या आपका बेंजीन है, इसको ड्रॉ कर दीजिए. आपका पाई बॉन्ड यहाँ पर है, नेक्स्ट आपका पाई बॉन्ड यहाँ पर है, एक पाई बॉन्ड यहाँ पर है, फिर यहाँ पर क्या है COOH. COOH is this one. C लिखते नहीं है, डबल बॉन्ड OH, राइट कंप्लीट. यहाँ पर क्या है CH2OH, CH2 then OH. C यहाँ पर है, दो बॉन्ड एक्स्ट्रा होंगे, मींस दो हाइड्रोजन्स हैं और एक OH ग्रुप है. यहाँ पे C, फिर यहाँ पे OH ग्रुप है, दो यहाँ पे क्या होंगे हाइड्रोजन एटम्स होंगे. That is how we write this compound bond line structure. So I hope it is clear that writing the compounds bond line structure. Okay. And then after writing bond line structure during practice, we will draw more structures, and from that you can understand easily writing the compounds nomenclature using the bond line structure of molecules. Okay. So let us take now next point here, classification of organic compounds, and then we start the nomenclature. Now next we can take classification of organic compounds. I am drawing one chart. That chart will draw first. Then I will explain the meaning of this chart. ठीक है? तो पहला chart को draw कर लीजिए पूरा and then I will explain the point to you. Now we can take organic compounds can be classified into broad categories. One are called as open chain, also called acyclic compounds or aliphatic compounds. They are open chain compounds without any ring. Example taken like ethane, propane, butane, hexane, pentane, so many compounds without any ring in the compound. We call them open chain compounds or acyclic. Acyclic means without ring, or aliphatic. They are also called as aliphatic compounds without ring, open chain compounds. अगला होता है closed chain compounds or cyclic compounds. This closed chain compounds or cyclic compounds can be taken two types again. One are called as homocyclic or carbocyclic, and one is called heterocyclic. इसका मीनिंग क्या होता है? One is called homocyclic. Compound cyclic होंगे, ring होगा इसमें. Now if the ring is made of only carbon atoms, the ring is made of only carbon atoms, no other element is coming in the ring, then the compound is called homocyclic or also carbocyclic. Carbon will make the cycle, so carbocyclic compounds. These compounds can be taken again two category. One is alicyclic and one is aromatic. What is alicyclic means? They resemble aliphatic compounds in the properties but are cyclic. Example can be taken like we can take here cyclopropane, cyclobutane, cyclopentane are common examples. 3-member ring, 4-member ring, 5-member ring. They are aliphatic type behavior but ring is there. And other called aromatic. Aromatic like two types here. One is called benzenoid structure resembling benzene, and other called non-benzenoid structure without benzene structure. Benzenoid you can have benzene itself, and resembling benzene is naphthalene, anthracene are common example taken in the benzenoid structure. In non-benzenoid they are aromatic but non-benzenoid. Like you can take one common example taken is this compound called as tropolone. It is aromatic nature but doesn't have benzene structure, so called non-benzenoid but aromatic compounds. तो एरोमेटिक क्या होते हैं, नॉन एरोमेटिक क्या होते हैं, इस पूरा हमारा टॉपिक पढ़ाएंगे आपको जीओसी में, जनरल ऑर्गेनिक केमिस्ट्री पार्ट 2 में. कंपाउंड क्लासिफिकेशन एज एरोमेटिक बिकॉज इट इज बिग टॉपिक. एरोमेटिक, नॉन एरोमेटिक, एंटी एरोमेटिक, व्हाट फीचर्स मेक देम टू बिलोंग टू दैट कैटेगरीज. So that all we'll discuss in general organic chemistry. Right now only just introduction part in classification purpose. अगला आते हैं heterocyclic. We told the closed chain compound can be taken two categories. One is homocyclic or carbocyclic. Second called heterocyclic or heterocyclic compounds. ये क्या होते हैं? Hetero means different. Cyclic means in the cycle or ring when we are having some other atoms apart from carbon, then we call them heterocyclic. Okay, that the ring will have some atoms apart from the carbon, then the compound is called heterocyclic. The compound can be taken again two categories, either non-aromatic or aromatic nature. Non-aromatic means like the condition of aromaticity is not favored here, fulfilled here. Example can be taken this one here. This compound is taken non-aromatic. कुछ भी आप ड्रॉ कर सकते हैं इसमें. It is non-aromatic compounds. May have pi bonds. Aromatic means like you can take furan, pyrrole, ये सारे आपको पढ़ाएंगे आप. इसके लिए बहुत टेंशन मत लीजिए स्ट्रक्चर के लिए. furan, pyrrole, we'll discuss all in topic एरोमेटिसिटी और एरोमेटिक कंपाउंड्स का क्लासिफिकेशन में या उसका आइडेंटिफिकेशन में कि एरोमेटिक कंपाउंड कौन से हैं, नॉन एरोमेटिक कौन से हैं, एंटी एरोमेटिक कंपाउंड कौन से हैं. आपको सारा उसमें पढ़ाएंगे इस चीज के बारे में, ठीक है। तो दैट इज द इंट्रोडक्शन हियर। ओपन चेन कंपाउंड मींस और acyclic I am again repeating few example wise, I write example directly. This kind of compounds can be called open chain without ring. Closed chain means rings are there. Homocyclic or carbcyclic means the ring is having only carbon atoms, no atom other than carbon in the main carbon chain. यहाँ पे क्या है heterocyclic, in the ring they have some atom more apart from carbon atoms which can be your nitrogen, sulfur, oxygen or other atoms are possible in the carbon chain. Apart from carbon, when we have some different atom, so name is heterocyclic. Hetero means different atom in the carbon chain ring structure. Non aromatic और aromatic, उसका condition होता है कि which compound can be non aromatic or aromatic, तो वो आपको पढ़ाएंगे in topic GOC, how to identify the compound as aromatic, non aromatic or anti aromatic. Using some rules are there, Huckel's rule, the compound structure is planar or non planar, they decide that point. Okay. That is the compound classification. Now we take compounds nomenclature, but if we take nomenclature, we take some basic points which are required to us, or for your betterment to understand, it should be clear to you. Now let us continue that some more terms required here. Like next point can be taken functional group. Already we have been reading this topic from earlier classes. In class 9-10 they introduced you some basic functional group. How we define this term functional group? It is definition, you can write down, note कर लीजिए. It is defined as an atom or group of atoms joined in a specific manner which is responsible for characteristic chemical properties of organic compounds. We can have a large number of functional groups. Just it is introduced right now here. Like we can have alcohols. In alcohol we have OH as functional group called as hydroxy. Then we can have aldehydes. CHO group is functional group in aldehydes. Then we can take carboxylic acid, COOH in them is functional group. Acid chlorides, COCl. So we will introduce a list of all the functional groups in nomenclature part. Okay, for different functional groups, how we write their names, prefix, because they can be named in prefix and suffix both sequences. So when they are named as prefix, for them what is name, or when they are named as suffix, then for them what should be name. So we will discuss in the sequence. Then next term can be taken here, homologous series. One common term they are using sometimes, homologous series. इसमें होता क्या है? In homologous series the compounds are having same general formula. They have same general formula and they will also have same functional group. They differ only in one CH2 group. So first we will take definition. What is definition of homologous series? A group or a series of organic compounds. It can be group or series of organic compounds each containing a characteristic functional group. They will have same functional group and forms a homologous series, and different members are called as homologs. The different members they differ. Different members will differ by one CH2 groups. The members differ by one CH2 group. They otherwise have same general formula. For them we can put there. Okay, so that is introduction of functional group and homologous series, homologs, and this difference is there of one CH2 group. In homologous series, different homologs or compounds are having same functional group, same general formula they possess. Okay, now after this we take the compounds nomenclature. For writing the compound names we will take two methods. One is called common names and one is called IUPSC names. So let us introduce to you common names. Like first we can take for the compounds. For writing nomenclature we will take two systems. One system is IUPSC nomenclature because common names are common for only some compounds. It is possible, it was possible earlier when the number of compounds known were very less. बहुत कम compounds थे जिनके बारे में हमें knowledge था. तो इसका नाम क्या है, compound का नाम क्या है, we will know easily. But now we know we have millions of compounds known to us. Then for their nomenclature we require some systematic approach. That systematic approach is called as IUPSC nomenclature. That we will discuss. Before that we can take first earlier how the compounds were named. The compounds were named depending on some sources from there they were obtained. Like common name, if we take here for some compounds, like we can take acetic acid. Acetic acid. It was obtained from vinegar. It is one of the main component of vinegar. The term acetum stands for vinegar. Next we can take here citric acid. Citric acid. It is found in citrus fruits. Found in citrus fruits. Citric acid. Methyl alcohol. Methyl alcohol found in wood spirit, or can take main component of wood spirit. Then you can take formic acid, formula HCOOH. It was found in red ants, for whom Latin name is taken formica, meaning red ant. So we can take, there are some common compounds, common names. These common names are coming from either source or from there they are obtained or found where. That decides, means origin or the source from where we can obtain, that is taken for the compounds common names. If you take formula wise, what is acetic acid? CH3COOH. It is big name, so I'm not writing here. Methyl alcohol is CH3OH. It is HCOOH. Some other compounds common names can be used here, which are given, like we can take CH3CH3, this compound called acetone. Then you can take here CH3CHO called acetaldehyde. Acetaldehyde. We can take then CHCl3 called chloroform. 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 We can take then CH3, CH2, 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 CHO. It is called as valeraldehyde. So we will take a list of more common compounds of organic compounds once we introduce to you different functional groups. In functional groups common names, we will explain to you how to write common names as per the compound functional group. Okay, so that is compounds. They are all called what here? They are called traditional names. They are traditional names or common names, or can take trivial names. This kind of nomenclature system is called as common system or trivial system or traditional system of writing the compounds names. This more example of this common names we will explain to you and we introduce to you different functional group structure wise and naming wise. Okay. Now next can be taken here, writing the compounds IUPAC nomenclature.